So, in last class I completed the arc power in details. I was also discussing about different categories of arc, welding arc, and I was also discussing about different categories of welding arc and different mode of welding arc in details last class. And today I will start a new topic that is actually called arc stability and arc blow. Today I will try to cover this arc stability and arc blow as well as forces affecting the metal transfer. So, first of all we should know what is arc stability and arc blow. So, before going to discuss about arc stability and arc blow, first of all we should know what is the function of current, because what happens to know details about arc stability and arc blow, first of all knowledge about current flow through the arc we should know. In case of a arc welding technique, what happens, let this is the electrode. I should explain and then we will go in details about arc stability and arc blow. Here what we observe that arc is arc cross section, actually we can say that this arc cross section, this gradually increasing from, let this is generally for cathode and this is generally anode, this is workpiece is anode. So, what we observe that in case of arc, this is arc, this is. So, what we observe, this arc is cathode means electrode, arc cross section continuously varying from cathode space region towards anode space region. That means cathode to anode region generally arc structure cross section is increases. So, what happens if the arc structure cross section increases, then what happens, there is a chance of concentration of the electron density, generally electron density corresponding to electron density, generally this current density, because electron density is responsible for current density. So, if the cross section increases, then the current density, then magnetic field strength and pressure all will be decreased, because depending upon the electron density, that means lesser the cross sectional area, more will be the concentration of the electrons, more will be the current density. That what I have already discussed in details, why this current density increase generally. So, here generally due to this varying cross section, that means increasing of cross section, here current density, magnetic field strength and pressure all decrease from cathode drop region, generally that means from this region towards the arc column and towards the workpiece region, because arc cross section increased rapidly in the arc column. Due to this rapid variation of arc column, generally current density, magnetic field strength and pressure all decrease from cathode drop region towards arc column. That idea we got. So, as this current density, magnetic field strength and pressure all decreases from cathode region towards the anode region, that is why generally what happens, there is generated varying magnetic field region. That means what due to this current density, what happens, we know what we know, if through a conducting medium, if current is flowing, that means if electron or current is flow through the conducting medium, around this medium generally what happens, they are developed generally magnetic field. So, let us current is flowing through this direction. So, here generally magnetic field that we know. Due to this current flow, generally magnetic field generate around the electrode, or you can say around the conducting medium. So, here also through the arc there is continuous flow of current is there, that is why through the arc also there will generate some magnetic field. This magnetic field strength higher near the cathode region and it is gradually decreasing towards anode region, and it is comparatively very less in anode drop region. Actually that we are getting also from here. So, due to this variation of this magnetic flux distribution around the arc from cathode region to workpiece region, here generally develops some radial pressure gradient and axial pressure gradient. Here due to this variation of this magnetic flux distribution through the arc, here develops some pressure gradient which is in radial direction as well as its axial direction, that means along the direction of current flow. So, because there is a axial direction, why this pressure gradient is creating this axial because this magnetic flux density is not uniformly distributed over the arc length. It is generally varying from cathode region to anode region. Due to that things, what happens, there is developed both radial pressure gradient as well as axial pressure gradient. Due to this radial pressure gradient, generally this radial pressure gradient constrict the arc. Whatever the radial pressure gradient it is creating along the arc, that radial pressure gradient generally responsible for constrict the arc. That means it's generally prevent the arc spreading. That means it's try to compress the arc to some confined space due to this radial pressure gradient. So, it's generally compress the arc, or you can say that it's generally constrict the arc, and what happens due to this constriction, the constriction of arc, here generally there is a rise of temperature is occur. There is a rise of temperature, more rise of temperature is occur also. So, the radial pressure gradient constrict the arc and rises the temperature of the arc discharge. So, radial pressure is responsible for these two. Whereas, whatever the axial pressure gradient is generating, that means due to this variation of magnetic fields distribution through the arc length region, there is developed some axial pressure gradient also. Due to this axial pressure gradient, generally what happens, this axial pressure gradient give rising to plasma streaming. This radial axial pressure gradient generally give rise to plasma streaming. This plasma streaming generally which transport the material and heat from electrode to workpiece. Due to this plasma streaming, whatever the electrode melt or droplet is forming, that droplet transferring from cathode region towards the workpiece region due to this streaming action. Apart from this function of axial pressure gradient, it's also help to create some turbulence action over the molten pool. It also exerts some pressure on the molten pool. Due to this turbulence action of this plasma streaming and creating some pressure over the molten pool, generally it helps to increase the penetration, that is it's increase the fusion depth also. That means this whatever the axial pressure it's developing, that axial pressure creates some pressure, let this is our molten pool, create some pressure over this molten pool due to this plasma streaming along this axial direction. It creates some pressure on the molten pool. Due to this pressure, generally it's increase the fusion depth also. So, plasma streaming function is to transfer the material from cathode to workpiece, as well as it also carry the heat from cathode to workpiece region, as well as it creates some pressure over the molten pool region of the workpiece. Due to this, it's increase the weld penetration. Now, here one thing we should keep it in mind, generally both this effect, that means both this radial pressure gradient as well as axial pressure gradient is dependent on current flow. It has seen that this radial pressure gradient and axial pressure gradient is proportional to a square of the arc current. Now, we will go what is arc stability, what is arc blow, because once we know the function of current flow through the arc, then we will be able to understand this arc stability, arc blow in details very easily. Now, first of all, we should know what is arc stability. Arc stability means arc is said to be stable when it is uniform and steady. That means, if the arc is uniform in nature and steady, if it will not varying, then what happens? It will not varying with time, then what happens? We can say this arc is uniform and steady, then this arc is said to be stable. Here one thing we should keep it in mind, that for getting a good weld bit and defect free weld, our arc should be, that means welding arc should be stable enough. If the welding arc will be stable, then only we can get a good weld bit as well as defect free weld nugget. That means we can get defect free nugget if our arc will be stable enough. Generally, this stability of the welding arc is governed by so many factors which can be mentioned as below. Like first of all, when we can get a stable arc, that means whatever the arc is developing in between a electrode and the workpiece, whatever the arc is developing, this arc will be stable. This arc will be stable. Generally, it depends on this arc will be the stability of this arc depends on so many factors. Like first of all, here we should know that means what are the different factors govern this arc stability. Here first things we should know, that means that the first point of arc stability is there should be generally suitable matching of arc characteristics and power source characteristic, that there should be suitable matching. That means here one thing, if there will be a suitable matching of arc characteristics and power source characteristic, then what happens, it will not actually, it should not actually, that means suitable matching of arc characteristics and power source characteristic means it should not extinguish its arc with a small variation of arc length or a small variation of arc length. That means if there will be a suitable or suitable matching of arc characteristics and power source characteristics is there, then arc voltage should not extinguish the arc if there will be a small variation of arc length. That type of matching should be there. That means suddenly it should not actually, due to a small variation, it should not extinguish suddenly. This is only possible once a suitable matching of arc and power source characteristics are there. So that is the first point. That means to be arc stable, first thing is its arc characteristic and power source characteristic should match properly. Then next point is, once this characteristics is proper, then what happens, whatever the emission and ionization occurs in arc column region, that should be also continuous and proper. If emission is continuous and proper through the arc and ionization also continuous and proper in the arc region, then what happens, our arc will be stable enough. It also depends on arc length. It has observed that lower the arc length, better the chance of arc stability. That means better the arc stability. And higher the arc length, there is a chance of lesser arc stability. That means there is a chance to deflect the arc and other thing. That's why we should keep the arc length as minimum as possible, then we can get better arc stability. It also depends on electrode tip geometry, especially once we go for using non-consumable electrode like GTAW process. Generally it depends on electrode tip geometry also. It has observed that higher the included angle, better the arc stability. What does it means? Higher the included angle means, generally in case of tungsten electrode, included angle means this angle is called included angle actually, alpha. This is tungsten electrode. Let this is tungsten electrode. So included angle is called this angle alpha is called included angle. It has observed that higher the included angle, better the arc stability. That means if the included angle is more, chances of getting more stable arc. That is generally, especially these types of included angle we observe in case of non-consumable electrode like plasma arc welding techniques, GTAW techniques, these types of things we observe. Now arc stability also depends on generally presence of dampness, oil, grease, etc. on the surface of the workpiece, generally increase the arc instability. So we should clean the workpiece, that means this presence of that means dampness, oil, grease, everything we should clean before doing the welding operation, before starting the welding arc. Generally this we should clean, then only we can get a good stable arc. Apart from this thing, it is also depends on the welder. That means it also depends on welder. Why? Because if the welder is experienced enough, then he can control this arc stability. So what happens here, another things we should keep it in mind, limited practice of the welder also, there can be arc unstable. So it's that means arc instability also depends on limited practice of the welder. So, apart from this thing, arc stability highly depends on polarity, that we should know. Generally, why? Because what happens, these are whatever the point I have told you, that is different point. Apart from this thing, it highly depends on polarity, especially the welding processes in which electrode is expected to emit free electron, like SMAW process, GTAW process, plasma arc welding process, where generally this welding processes generally here electrode is expected to emit free electron, required for easy arc initiation and arc stability. For the requirement of, that means for the requirement of easy arc initiation and arc stability, here selection of polarity is highly essential. That means proper selection of polarity is required. That means selection of polarity affect the arc stability a lot, especially in this welding process where generally electrode is expected to emit free electrons. Here generally, first of all, we should know generally what types of polarity generally gives better arc stability. It has observed that both consumable as well as non-consumable types of electrode, generally DCEN, that means DCEN, that means electrode negative polarity gives better arc stability. Generally both these consumable electrode as well as non-consumable electrode, generally we get better arc stability if we use electrode as negative. But always this negative is not good, though it is good for arc stability, but sometimes DC-EP also required to put there. That means electrode positive terminal also sometimes required to put, because what happens, the electrode positive have some good effect, which though not help the arc stability, but it has some other good effect also. That also we should know. That I will tell in details here. Electrode polarity here, what I have told, that to get a stable arc, what are the things required? This electrode should always keep negative. That means DC direct current electrode negative polarity give more stable arc, both in case of consumable electrode and non-consumable electrode. Like in case of consumable electrode, generally like in SMAW, that means shielded manual metal arc welding, using copper electrode, this copper element should have low ionization potential, and if it is connected with DCEN, then generally it provide better stable arc, than DCEP. But here one thing we keep it in mind, as in case of consumable electrode, electrode is carrying current as well as it transfer the molten material, that means drop of material from electrode to workpiece. That is why here generally we keep it in, as it's the droplet is transferring from electrode to workpiece. That is why for better metal transfer, generally DCEP is preferable. Though we are getting why, that I will discuss in detail in subsequent slide. Here one thing keep it in mind, that better stable arc we get in case of DCEN, but with DCEP generally give smoother metal transfer in case of consumable electrode. Whereas in case of non-consumable electrode welding like GTAW welding, here tungsten electrode is expected to emit electron for providing a stable arc. Therefore, here DCEN is commonly used. Always keep it in mind. For non-consumable types of electrode like tungsten also, there we use DCEN, which generally give a stable arc. But generally for some material like reactive material like aluminum, magnesium, titanium, for this type of material once we go for doing welding, there we should use DCEP, because DCEP provides some good action on these types of material. So some exception is there. So what we get from here, that means once we go for consumable electrode as well as non-consumable electrode, generally direct current electrode once it connected with negative terminal, that means DCEN polarity gives a stable arc, both the case. But sometimes DCP is required, like in case of consumable electrode, for smoother metal transfer DCP is good. Similarly, once we go for non-consumable electrode like GTAW, gas tungsten arc welding process, they are generally for reactive metal, especially aluminum, magnesium, titanium. Once we go for doing this types of material welding, then what happens, they are generally DCP is sometimes DCEP is required, because it has some good action on this types of materials. Some well quality we can get by using DCEP. But a stable arc will be generated by DCEN. Always keep this thing in mind. Now, so we got the idea about arc stability. Now we should know what is arc blow. It's the opposite thing. That means whatever the stability we got, arc blow is opposite thing. Opposite thing means here generally disturbance of arc is there. That also we should know. What happens if there is a disturbance of arc is there, then what happens, that we should know. What are the different categories of disturbance of arc? What are the different categories of arc blow? That means blow of arc is there, that we should know. First of all, the definition of arc blow, we can tell the unwanted deflection or the wandering of welding arc from its intended path. From its intended path is termed as arc blow, or it is sometimes called as arc bow, because here arc generally deflect its intended path. So its shape can be like curve, which is generally resemble with bow. That's why sometimes it's called arc bow also. So arc blow generally developed due to the flow of current through the arc. This is the main reason of arc blow. Always keep this thing in mind. When this arc blow occur, once there will this is so arc blow is the result of magnetic disturbance. That means all the current is flowing, there we have I have already told you, there generally develop self-induced magnetic field. So what happens, once this magnetic field is disturbed, that means this arc blow is the result of magnetic disturbance, which generally unbalance the symmetry of self-induced magnetic field. Because if there will be magnetic disturbances, then what happens, there will be that symmetry of the self-induced magnetic field will not be there. So if there will be that means asymmetry of magnetic field, then their arc will not be able to retain its original shape or original path. Then this arc shifted to its intended path to another direction, or it generally change its shape. Due to this change of its path, generally what happens, this arc blow occurs in the workpiece. So arc blow is the result of magnetic disturbances which unbalance the symmetry of self-induced magnetic field. So generally due to this asymmetry of magnetic field distribution, arc blow is occur. This asymmetry of magnetic field distribution is occur through the arc as well as electrode as well as workpiece, because what happens, wherever there will be a flow of current, there will create a magnetic field. So what happens, if there will be magnetic disturbance, then everywhere this magnetic self-induced magnetic field also disturbed. Due to this disturbance, generally what happens, this magnetic arc blow is occurs. Arc blow becomes severe once the welding is carrying in a confined and corner on a heavy metal plate, especially once we use DC current. Why in DC current this magnetic arc blow is severe, that we should know. Generally what happens in AC current, that is why here in next slide I will show you why this is severe in case of DC current compared to AC current, that also I will explain here. Generally AC arc are less susceptible to arc blow than DC arc, because AC reverses direction. Generally we know in every cycle of alternating current there is a zero crossing, that means there is a positive flow as well as negative flow of current is there. Due to this reverse direction, the magnetic field build up. That means here collapse and rebuild of magnetic field risks occur as the current reverses from positive to negative direction. Due to this collapse of magnetic field and rebuild of magnetic field, here generally magnetic field cannot build up to such a high value so that it can create arc blow. Because what happens, due to this cyclic variation of current from positive to negative terminal, due to this alternating current, here generally magnetic field cannot build up such a high value which can generally produce some arc blow. That is why in case of AC current, arc blow is rarely found. Whereas on the other hand, in DC welding, the magnetic field setup in workpiece continuously build up and the arc blow occurs. Here what happens? In DC current there is no such reversing is there. So, here generally continuously magnetic field build up taken place. Due to this continuously magnetic field build up, what happens? Here there is a huge chance of arc blow is there. Now, we will go what are the different factors generally affecting this arc blow. Generally magnetic field produced in workpiece, what are the factors affecting the arc blow, that also we should know. The main factor which affect the arc blow is magnetic field distribution. Generally this magnetic field produced in workpiece adjacent to the welding arc due to current flow through the arc, what I have already told you. So, the main factor is magnetic field distribution. So, wherever there will be a disturbance of magnetic field, there will be chances of arc blow. So, that is why generally with multiple welding head, where there are two different magnetic multiple weld head, generally how it look like, instead of single arc, generally sometimes we use continuously 2-3 arc. So, what happens along this first arc, there will be a distribution of magnetic field. Similarly, in second arc also there will be a distribution of magnetic field. So, what happens due to this multiple welding head, arc at one, that means arc at one head can affect the arc at other head, means that means due to this distribution of magnetic field, one magnetic field can disturb the other magnetic field. Due to this disturbance there can occur arc blow. Apart from this thing, the magnetic field produced in the workpiece around the earth connection may tends to drive the arc away from the point where this connection is made. So, due to this arc clump also there is a chances of arc blow also. This because what happens here generally current is flowing from arc that means earth clump to workpiece. So, wherever there is a flow of current, so there will generate some magnetic field. This magnetic field can create arc blow once this arc is passing near the earth clump region. Okay. So, these are the generally main factor which govern the arc blow. That means, the main factor of arc blow is magnetic field disturbance. This magnetic field disturbance can occur in different way. That what I have told you. It can occur due to multiple welding head. It can occur due to multiple welding head as well as it can occur due to this earth connection. So, what happens? These are the factors generally which affect the arc blow. Now, we will go what are the different categories of arc blow. Depending upon the above factors, this arc blow generally categorized into 3 different categories. What are the 3 different categories? A forward arc blow at the starting end of a weld and a backward arc blow at the finishing end of the weld. So, this is generally, that means forward and backward arc blow. A sideward deflection is another arc blow and arc rotate is another arc. So, these 3 different categories of arc blow can be there. So, forward and backward arc blow can be there, a sideward deflection or sideward arc blow can be there, or arc rotate also is another kind of arc blow. Now, I will discuss in details about this forward, backward, sideward and arc rotation types of arc blow in details. So, first of all, forward arc blow. Generally, forward arc blow taken place at the starting end of the weld and backward arc blow taken place at the finishing end of the weld. Why? Because generally magnetic flux line get crowded near the starting and finishing end of the workpiece, because they find an easier path, generally they find an easier path through the workpiece than through the air. Always keep it in mind. Generally magnetic flux line pass through the workpiece rather than passing through the air. So, it is crowded, instead of passing through the air, it passes through the workpiece, because it get easier resistance in workpiece rather than air. Generally magnetic field, that we know actually. That is why the arc seek the path of least resistance and deflect toward the weak flux side, because what happens, due to these types of magnetic flux distribution, generally concentration of magnetic flux is more at the starting end as well as at the finishing end of a weld line, because there is concentration of magnetic line will be more. So, due to this more concentration, here the resistance will be more near the starting end as well as near the finishing end. So, what happens, due to this more resistance, generally arc deflects away from that side. That means arc deflect away from static end side as well as arc deflects away from finishing end side towards less concentration flux distribution region. That I will show you in details by drawing the thing. That means which causes the flow forward arc blow at the starting end and backward arc blow at the finishing end of the weld bit in the workpiece. How it is, that I will show now. Like here, what happens in case of welding, let this is a weld plate. Near the starting end, let this is the arc, this is the electrode, similarly this is the starting end, let this is the finishing end. So, what happen at a starting end as well as in finishing end, generally arc deflect like this. Why this deflection is taken place? Because so what happens here, generally this concentration of this, here you see one things you can observe, the concentration, let this is the magnetic field concentration. This is the welding direction, actually welding direction. So, here we see at the starting end, that means near this position, actually this arc should be near to here. Okay. Generally here the concentration of this magnetic field line is more, because this magnetic flux line pass through the, instead of passing through the air, it's try to pass through the workpiece. It generally passes through the workpiece, because that's why generally here crowding of magnetic field line is more than this other side. So, what happens, that is why here this side generally we get less resistance than this side. So, due to this less resistance, generally arc seeks the path of least resistance direction. That is why in the starting end generally arc deflect, this arc deflect in this direction. So, whereas at the finishing end, here also similar thing occurs, that means this flux line density, generally flux line density here also occur like this. That means concentration of this flux there is one things we can observe. In this side also, here we see, that means flux line density is more, that flux line density is more compared to this side. This is density, flux line density, here density of flux line is more, magnetic flux line is more and here generally density is less. Density is less. So, what happens due to this, generally arc deflect toward the less region, means where the density of the once the density of the flux line is less. So, in that direction that resistance also will be less. If the density of the flux line is more, there the resistance will be more. Due to this, generally the arc seek the path of less resistance and deflects toward the weak flux side, or we can say less flux density side, it is deflect. Due to that, what happens in case of arc welding technique, at the starting end and at the finishing end we get, so this is called forward arc blow, the starting end whatever the arc blow is occur, this is for forward arc blow, and this is called generally backward arc blow. So, why it is occur, that we understand. This is occur due to the crowdness of magnetic flux line near the starting end and finishing end of the weld line. These two different types of arc blow is occur. So, if we see the side view of these things, what we observe, generally in middle region of this weld, generally in the middle region, in this middle region we will get a stable steady arc generally. Here in this middle region, that means apart from a start and end region, in between we get a stable arc, or you can say that non-deflected arc. So, generally if you see the side view of this thing, at the starting end generally we get a arc which is look like this, at the finishing end we get a arc which is look like this, and at the middle region generally we get arc which is look like this. So, what happens here, starting end arc is deflected, finishing end arc is also deflected, but in between generally arc is not deflected. So, this is forward arc blow and this is generally called backward arc blow. This is the direction of welding. Okay. So, we get idea about forward and backward arc blow. Now, we will see what is sideward arc blow. Generally, sideward arc blow depends on workpiece earth clamp. That means, we know that generally in case of welding there is a earth clamp connection, one connection coming from earth to earth clamp connection is there with workpiece, and another terminal is connected to what is called electrode, that we know. So, what happens, this sideward arc blow generally occurs due to workpiece arc clamp. What happens, as the arc comes near the arc clamp, it deflects sidewardly in a direction away from the clamp, perhaps because of the magnetic flux enacted in the workpiece by the arc clamp. This magnetic flux generally is produced by the flow of current from clamp to workpiece. Whatever the magnetic field here it is producing, that is produced because there is a flow of current from earth clamp to workpiece. So, wherever there will be a flow of current, there will be magnetic field distribution. Due to this magnetic field distribution, generally what happens, once the arc come near to this earth clamp position, generally it deflects sidewardly in a direction away from this earth clamp. It is also noted that as the arc crosses the earth connection, it has a tendency to come to the original line of travel. That means, arc has a tendency to come to the original line of travel. This is how it look like, that I am showing here little bit, then it will be more clear to you. Let this is a weld plate. This is a workpiece. Now, in this workpiece welding is required to do. What happens here, the earth connection is there. Here we put the earth clamp. This earth clamp connected with this cable. Generally this is generally called ground cable. This is called earth clamp. So, generally what happens, due to the flow of current from earth clamp to workpiece, here generally develops some magnetic field, here generally develops some magnetic field, here generally develop, because there is a continuous flow of current from earth clamp to workpiece is there. So, what happens, due to this, once this welding come near to this region, it deflect like this. So, how the welding is look like here? Here the weld bead is look like here. Let this is the weld bead. So what happens on the welding are coming to, so this is generally deflected weld bead actually. So, what we observe here, due to this earth clamp, generally here arc shifted to its intended path. That means, it is not going to through the straight line. Instead of going through a straight, it deviate. That means, arc is deflected away from this earth clamp direction sidewardly. Okay. Due to this, generally here generally weld bead we get, which is deflected sidewardly, but once it cross this earth clamp position, then generally it's return back to its original line. That is like what happens if it is just cross this position, it generally again it's return back to its original weld line. So, this types of arc blow is called sideward arc blow, because here generally arc is deflected sidewardly due to the position of earth clamp. Now, we will see what is the different effect of arc blow and what are the remedies of arc blow, that also we should know. Apart from this thing, we should know what is arc rotation. Here generally in the last two cases what we have observed, generally arc deflected either forward direction, backward direction or sideward direction. Here instead of here not only arc is deflected, here arc is rotated also. That means, here rotation as well as arc deflection is taken place. Due to this, generally what happens here, bead shape is look like wavy in nature. That means, is some sort of rotation as well as deflection type shape of weld bead generally here it is observed. This arc rotation indicates that under certain condition of arc blow, perhaps arc experience magnetic field line parallel to the arc axis. Generally what happens here, what we have observed, generally magnetic flux line generally generated in transverse direction. That means, what we have observed, generally magnetic field line is generated in periphery direction. That means, in transverse direction. Instead of magnetic flux line generated transverse direction, here generally these types of things can happen. That means, perhaps I experience magnetic field line here parallel to the arc axis. Along arc axis, here it is also magnetic field line here can be generated parallel to that arc axis also. Due to this, generally what happens here, these types of arc rotation as well as arc deflection is occur. This is generally another third categories of arc blow. The reason of this thing I will discuss in details once I will discuss the metal transfer actually, that means drop transfer in case of welding process in detail. Generally, the reason of this arc rotation and arc deflection is due to very high current, and what happens due to this high current, generally this high heat is generated. Due to this high heat, generally this electrode cannot retain to its original state shape. So, here generally electrode itself deflect, and due to this high heat, this electrode tip generally become plasticized and soft enough, and what happens, electrode tip become deflected shape. Due to this deflection of electrode, generally what happens here, due to this deflection of electrode, here generally there create asymmetry of magnetic field distribution. Due to this wavy nature of this electrode tip as well as asymmetric distribution, that means asymmetric distribution of magnetic flux, here generally create two different types of forces. These two different types of forces, what is these two different types of forces here it is created? Here generally one forces is radial forces and another forces is along its transverse direction, that is called azimuthal. Generally this is called azimuthal forces, which is developed generally in case of arc rotation. Due to these two different forces, that means radial force and due to these two different forces, that means asymmetric radial forces and azimuthal forces, due to these two different forces, that means asymmetric radial force as well as azimuthal forces, generally what happens here, these types of arc rotation as well as deflection is taken place. This I will discuss in details once we will discuss the metal transfer. There generally these types of phenomena I will discuss in detail. Now, what are the different effect of arc blow? Arc blow has significant effect on weld qualities. Due to the arc blow, generally there create different types of weld defect in a welded sample. Generally what happens, this arc blow have a very tremendous effect on quality of welding, because where there will be arc blow, there will be generally unstable arc. This is the main things is there. So, once there will be unstable arc, there we will get poor weld bit appearance, there we will get irregular and erratic weld deposition, because if the welding arc is itself unstable, then generally these are all different defects which arise due to this effect of arc blow. Then there can be undercut, lack of fusion due to this arc blow, because here welding arc is unstable in nature. There can be a spatter due to this arc blow, there can be uneven and weak welded joint, there can be slag entrapment, and there can be porosity. So these are all defects which can arise if there will be arc blow. Now, how to eliminate this arc blow or how to minimize this arc blow? So, we should know what are the remedies for arc blow. It can be minimized by keeping the following factors in view. Generally, whatever the factors I have showing here, if we just follow this factor, then we can minimize or eliminate the arc blow. Like generally what I have told you, one of the cause of this arc blow we know, that means at a starting position and finishing position, as there is what it is called air gap. So, that is why this flux generally cannot instead of passing through air, it generally concentrate toward the workpiece region. Due to this generally concentration of arc flux is there over this region. So, if you can provide a run on and run off plate generally, then what happens, this arc can pass, that this magnetic flux can pass through this, what happens, then there we can get more or less uniform types of magnetic flux distribution, so that we can at least minimize or we can some extent eliminate the forward and backward arc blow also by providing some run on and run off plate. That means by which generally that magnetic flux distribution can be uniform. We can make the magnetic flux distribution more or less more uniform. Another reason of this arc blow is due to this arc clamp. So, changing the position of arc clamp and welding away from the earth connection. So, if we do this welding operation far away from this earth clamp position, then what happens, there is a less chance of sideward arc deflection also. So, we should put our earth clamp far away from this weld line. So, by this also, and apart from this thing, instead of one single earth clamp, if we provide opposite side another arc clamp, there due to this what happens, due to this balance, that means effect of two different arc clamp, there is a chance of less deflection of the arc. So, this first point is changing the position of the arc clamp and welding away from the earth connection can eliminate or minimize the arc blow. Then what are the another reason is storing workpiece away from the magnetic source. That means another source of arc deflection is source of magnetic field. So, what happens if we do the welding near a magnetic source region, then what happens, there is a chance of more arc deflection. So, what happens, once we do the welding operation away from this magnetic source, like one of the magnetic source in case of welding operation is magnetic power source itself. So, we should keep the power source far away from the welding region, then generally there is a less chance of what is called arc blow. Then employing ground connection more than one, what I have told you, that means ground connection means earth column more than one. Using short arc, generally I already told you, generally short arc give a stable arc. So, once there will be a stable arc, in case of short arc chances of deflection also less. Then lowering the arc current also, if the arc current will be less, then definitely the magnetic field intensity and other things will be less. So, there is a less chance of arc deflection also will be there. Now, thus another point is using a smaller diameter electrode. If the diameter of the electrode will be smaller, then what happens, there will be generally less chance of arc blow. Then decrease the travel speed, that means whatever the welding speed by which that welding is carrying out, that travel speed, by decreasing that thing also we can minimize the arc blow. And the last point we can say, superimposing a counteracting externally applied longitudinal magnetic field, by superimposing this thing also we can minimize the arc blow. So, these are the different factors. Generally if we just keep this thing in mind, then we can minimize the arc blow a lot. So, now we have seen about arc blow as well as arc stability in details. Now, we will go metal transfer. Here what we should know before going to metal transfer, first of all here what we should know, what are the forces generally affecting metal transfer, that we should know. So before going to details about metal transfer, here one thing we should know, before going to metal, first of all we should know what are the different forces affecting the metal transfer, then only we can be able to understand the metal transfer in details. In case of metal transfer, there are two different types of forces affecting that metal transfer or drop transfer from electrode to workpiece. This is what I am discussing here. This is for consumable types of electrode. Consumable, that means this electrode generally melt, drop, form, and what happens, there is drop transfer from electrode to workpiece. These types of things. So, consumable types of electrode cases generally I am telling, because metal transfer is taken place in case of consumable electrode. Na? So, generally there are mainly two types of forces affecting the drop transfer. One is called aid metal transfer forces, another one is called retard metal transfer forces. What is aid metal transfer forces and retard metal transfer forces? Aid metal transfer forces are those forces which helps to detach the droplet from electrode and which helps to transfer that drop from electrode to workpiece. Generally the forces which help for detachment of that droplet from electrode as well as transfer from electrode to workpiece, that force is called aid forces. That means which helped for metal detachment as well as transformation. Another forces is called retard force. Retard force which oppose this thing, that means which oppose this effect, that means which oppose this metal detachment as well as metal transfer. These forces is called retard metal transfer forces. In general, in case of a metal transfer phenomena, there we got different types of force. What are the different forces? Like there can be surface tension forces. In general, there can be viscosity forces, there can be high velocity gas jet forces, there can be gravity force, there can be another force is Lorentz force. So, these 5-6 different types of force we observed in case of drop transfer. Generally, some of these forces is aid metal transfer force which helps the metal detachment and transfer, and some of the force which generally oppose that phenomena, that means which oppose that detachment as well as transfer of metal. So, which force is opposing and which force is detaching, that I will discuss in details about these different forces in next lecture. So, I will discuss about all these forces. Apart from this thing, I will discuss about metal transfer actually, which occurs in case of consumable types of electrode. So, that I will discuss in next lecture.